Today I will just briefly introduce to you one of the research I have done. So can you see my slides now? Mo, can you see my slides? I'll just make sure.
Yes,
okay.
we can.
Yes, okay, you can see it, okay. Sure, so today the webinar topic is about an exploration of fuel poverty in the private rental housing market in city of Glasgow. As more introduced, I'm a lecturer in urban analytics in the University of Glasgow and also based in Urban Big Data Center, which is one of the research center and also a data infrastructure funded by the UKI Economic and Social Research Council, and we call it ESRC. So just a bit of the personal introduction of myself. So the general research interest I have is to using urban analytical approach to solve social, economic, and environmental problems in our cities. Particularly with the new forms of urban big data right now. So comparing to the probably 10, 20 years ago, we have the traditional urban data. But by under the big scene, the research scene, few approaches I use, including the GI science, all the way back to my original background in remote sensing and geographic information systems, also photogrammetry, and also using some of the spatial analytical methods. But besides that, in the more geography urban planning background, I have also used many different other things, such as machine learning, so general statistics, operations research, and you probably heard about it, and people call it optimization. Sensor network, so it's less like the remote sensing, but it's like connecting all the different sensors, sensor network, stationary sensor, portable sensors, etc. And also I've done a piece of work on urban climate modeling and instrumentations. So that's the approaches I use in my research, and many things can be adding up later on. In terms of teaching, so I handle 3 master courses in the University of Glasgow, and I'm also a master in urban analytics course convener here in Glasgow. And actually, Rekha is one of our very best students from the first year of the master urban analytics. So she's helping today and for us. So the course I teach, including the big data urban analytics, more like a conceptual understanding of the big data and urban analytics. The programming tools talk about a few different programming tools, including Python, SQL, and R. And yeah, today in the second half of the tutorial, I will talk about some of how I actually achieve my research results through a Jupyter Notebook. And also the final course I teach is called the Urban Analytics Group Project. So that's the kind of particular course for all our students. Basically, 3 or 4 students work together as a group. And then we have some of the real work group projects from industry, from the academic, from third sector. And they work together for 3-4 months. So if you're interested in more of my background, feel free to go to my website to look at it. And also you can look at some of my publications there. So yeah, Mo already briefly introduced the Urban Big Data Center. And I just want to give you a slightly more introduction here. So Urban Big Data Center is a research center right now. And that is jointly funded by ESRC and the University of Glasgow, starting from 2019 to 2024. And we're already here for 10 years. We get started in 2014. And the first 5 years, we serve as a data service center. And the second 5 years, we switched to research center, but also maintain our data service continuously. So the general objectives of UBDC is we try to promote the use of big data and innovative research methods to improve social, economic, and environmental well-being in cities. Very, quite broad, but I will talk more examples today to let you understand how it works. So a few pillars of our center, like including world leading urban research. That's what we want to do. And we also host a very good amount of data collection and data surveys, which means you can go to UBDC website. And I see more share that in the chat channel as well. So you can go to that website and you can find out many data there, and you can apply to, and particularly for a few of the commercial data set, typically you need to pay to obtain it, including the Zoopla data I used today. But through UBDC, if you want to do non-commercial research, you can actually go ahead to apply, and we will share the data with you under the formalized data license. We also done teaching and capacity building. Like today, one of the data, we have a series of data dive events. So that's actually helping more people, more audience to understand how to use the new forms of data in urban research. So in UBDC, you have 4 existing research package, including education, urban governance, housing, and transportation. And we will soon open a new research package called Urban Sensing and Analytics in the due course. All right. So after a brief introduction of the background, and I will go to the research today. So today we'll talk about field poverty, right? So first thing is like why that's emerging questions we want to look at. And I just find out some interesting statistics here. So on the left-hand side, that's the rise of field poverty in the UK. And you can find out back to 2002, there's 1.3 million people under field poverty, and that's about 20% of UK households. But after 10 years in 2012, we actually get 6.5 million people, 25% of the UK households under field poverty status. And after 4 years, we got even more in 9 million people, and basically 32% of UK households under field poverty. And I'm sure if we have a figure for 2020 under the COVID-19 situation, we'll probably get more people because the economy is actually heavily hit in UK. So we keep seeing the increasing of the field poverty status, not only in UK, but in many other places. So how to actually help them, what actually cause the field poverty? And the government is actually thinking of problems, right? So it's thinking what's the solutions. So people need to spend a lot of fuels, pay a lot of money to actually make, during the winter in UK, they can make the home warm enough. So on the right-hand side, the Scottish government published a new roadmap about how to improve field poverty over entire Scotland. And that's from the report, and you can see down in the second reference, that's a government publication called Guide Field Poverty Target Definition Strategy Scotland Bill back to 2018. So it says the homes with field poor households to reach EPCC, basically C band. So just give you an idea. So A is the best in terms of the field, in terms of the energy performance in UK, and the G is the worst. And it says if the household is under field poor, by 2030, their house needs to reach EPCC, and by 2040, it needs to reach EPCB. But you will need a lot of, I would say you will not need a lot of investment because a house needs to be updated, and there's many, field poverty is not only the house, right? It's not only the building, but also the income level of the population. So that's, from these two figures, I just want to give you a brief ideas like how it is emerging of this question. So to understand field poverty, so we have a few different methods. So the traditional methods, including the household and the building survey, is basically traditional ways to do, and you think of like sensors, like people that go into the household and ask like how much money you spend on your electricity and gas. And also the building building companies, they actually go to look at each of the building and see, oh, what's the energy efficiencies in terms of the building itself and also the appliances. And a few other methods, a few other literatures that they use the official statistics. They say they use the census data, whatever in different countries. And also they obtain the energy cost data from the electricity companies. And they use those data to look at, to understand, right? So from the census, they can obtain the income data for the household. And also they also have the energy cost. They can understand, okay, so how much money you spend on energy compared to your overall income, and is that a particularly high portion of the percentage there. So that's one way to look at it. And also there's a lot of, fuel poverty is more like energy policy questions. So a lot of policy debates, discussions around this topic. And if you go into the literature, the Baker etc. 2018 is a common paper published in Nature Energy, I believe. It's one of a very good journal. And it talk about, the fuel poverty, how it looks like, and the qualitative and conceptual discussions, and how to actually achieve it, what's the factors to influence it. So yeah, so this is the brief literature review, like how it looks like in the academic literature review. But what's next? So that's the question. Is there any other way to actually tackle this problem? So yeah, so basically here in this analysis, today I want to share with you is try to use some of the new forms of urban big data to understand fuel poverty. So the data we have, including the Zoopla data. So many of you, I know today the audience is from all over the world, so you may not quite familiar with Zoopla, but it's similar to like online platforms. If in US, you probably use Zillow and say Redfin. In UK, you probably use Rightmove as well. And Zoopla is also another one of the largest online house rental and selling platforms. And if you're in Asian, and I noticed there are many similar platforms there as well. So Zoopla data includes, say, the rental price, it includes many informations, including when they actually post it. And so a series of data will post it online, and people can actually look at it and to choose the rental property or like buy or sell their properties. So luckily from UBDC, we got a budget to purchase a portion of the Zoopla data. And I will talk more later in the slides. So they provide the data to us in a machine readable format in CSV. And in the second half in the tutorial, I will actually show you a summary of the Zoopla data. So this data, I cannot really put it on GitHub right now because it needs to go through a data license, because that's a commercial data set. We purchase it and we have agreement with Zoopla and say, they allowed us to share with people if they want to use it for non-commercial research, but everything needs to go through the UBDC entire paperwork, and you will eventually get a delivery of the data. And EPC data, it's come from the government. It's more openly available. And you can imagine, so right now there's a wave of kind of people like, researchers, public, stakeholders, like just shout to the government and say, oh, can you just make more of the government data openly available, because that will give more and more benefits to the entire society. I'm not quite sure, I don't know about your background, but one of a very good example is the satellite image, one called Landsat from the United States. And back to, I think, about 12 or 13 years ago, they started to make it entirely free. And actually making it free, adding much more values to the entire society, comparing to put the data under the paywall and receive the money just by selling the data. So that's one of a very good example. So the EPC data right now is getting more and more widely available. So for England and Wales, you can actually download full EPC data online through their portal, and they provide a pretty detailed information. I think they provide a full postcode. For Scotland, you can download the individual data on the Energy Saving Trust website, and I will show you later. But for the machine readable data, the Scottish government, in terms of privacy consideration, they only give us the postcode sector, so which is not a full postcode. But we are trying to push that for the government to release the full version of the data set, and that will help us to better understand. So yeah, a bit more on the Zoopla data. So as I mentioned, you can obtain through the UPDC data surveys. There's a link, and also if you go to the my GitHub repository for today's seminar, and you can find out the links on the top of the notebook. And just a brief idea of the data range. The data I have is from the January 2010 to end of March 2019. And we'll continue to receive data from them because we're kind of negotiating contracts with them to get a continuous coverage of the Zoopla data. So all data is 188 CSV files, and totally 44.3 gigabyte, which is certainly a big data. It's not something that you can handle by using Microsoft Excel or ArcGIS. So it's not something can easily be handled by traditional software. So the coverage we have, including England, Wales, and Scotland, and the geography unit, we have a full postcode for Zoopla data. And actually for each of the Zoopla data, we also get some address information and also a link to the real Zoopla website. So if we want to really go further, we can look at those information, see if we can really identify the address. But that will be a bit more complicated because it involves some of the tax analysis, etc. So for the EPC data, you can obtain through the Scottish Government website, and for the machine readable CSVs. And as I said, if you want to find out individual houses, like say you rent a flat or you purchase a house in Scotland and you want to see what's the EPC, typically you will get it because if you have like those kind of activities. But if you want to look at some other people's, you can go to the Energy Saving Trust. There's a link, and you can type in the postcode and you can find out if there's a archive EPC certificate. Excuse me. So the EPC data machine readable version, the time range is from October 2012 to March 2020. And the EPC data is actually 2.5 gigabytes with 30 CSVs. The coverage is for Scotland. And the geographical units of postcode sector. But as I said, England and Wales, they have a different portal, and it covers the English coverage pretty good, and Wales it's about half of a coverage, and it has a geographical unit to the full postcode. But from my discussion here for these two data sets, you can find out these two data are not a comprehensive representation of the entire either the private rental market or the EPCs. So the Zoopla, only the houses or flat under advertisement, you will get information. If some flats, the homeowners live there for 30 years, it never going on the market, you will not get information for that information, for the data, right? For the house. So for the Scottish EPC, there also is a few regulations. I will talk about that more details in the tutorial, but generally speaking, only those houses required to take the EPC and you will get information. So a few other data, we're including the, so to understand fuel poverty, right? So one of the very important things, the income level. And for Scottish income information, I think they stop in the census to obtain that information, but they have a weekly household average income from another housing survey. So here's the data I use. And because we have different geographical units, the weekly household average income is under the data zone level, and the postcode sector for EPC data and full postcode for the Scottish, the Zoopla data So we need to have some data alignments through different spatial units. So I use the Scottish postcode directory files from the National Registration of Scotland website. So yeah, so go to the analysis. So we have the Zoopla data pretty big, 44 gigabyte, but how it looks like internally. And I just get excited every time to play around with the data and find out that's kind of very explore the unknown situation. And when I first read the data in, and it takes about 5-7 minutes to read the entire data set into my Python Jupyter notebook. It's an original data is 1.3 million rows of the records, all the way for about more than 8 years of the data. And I further narrowed down to Glasgow, the big Glasgow regions. So it's not Glasgow city, but a big Glasgow region. And it narrowed down from 1.3 million to 124K records. And then goes to the Glasgow city, and I use the particular postcodes we understand like a central area of Glasgow city, and that's 71,000 rows of data. And particularly, we're interested in the private rental market right here. So in the Zoopla data, there's a column name differentiate the rental property and the homeowners. And after ruling that out, the data further reduced to 18,000 rows. And after this, the first 4 steps of the filtering, we kind of sort of got the rental properties information in Glasgow city in Zoopla data. And next step is doing more of the data cleanings, including removing the missing values, remove outliers, some of the rental price, and hugely, it's kind of unbelievable. I would say probably one is that's an error, or that's a kind of a very, very expensive house. People try to rent it out. So we remove those outliers because we look at few properties, right? So we look at the low incomes and the low rent. And also in terms of a time range, we need to correspond with the EPC data. So if you still remember, we have a Zoopla from 2010 to 2019, and EPC data from 2012, end of 2012, and all the way go to the 2020. And in this analysis, I use the data between 2013 to 2018, I believe, to just make sure that both data cover the same period of time. But after doing all those data cleanings, we further remove 3,000 data rows. And then the final step is to calculate the yearly rental cost at a postcode sector level. So it involves some of the data manipulations, and that I will present that later in the tutorial. So after the first step for the Zoopla data, which is the probably most exciting and most time consuming, and I go to the EPC data, it's much better because the government, certainly they have their data scientists, they already clean the data in a very good format. And for the EPC data first, I filter the time range to match with Zoopla data. And then I calculate the unit energy cost per year per square meter from the EPC data. So in EPC data, they have a column called a current energy costs in the next 3 years. And then they also have the indoor areas for the house or for the flat. And so I can easily calculate these measures from the EPC data. And the next step is actually join the EPC data with the Zoopla data based on the postcode sector. And after the spatial join based on the postcode, and I calculate the energy cost per year based on the bedroom numbers through Zoopla and the unit energy cost through EPC data. So I found a reference here. So it says in UK, generally speaking, one bedroom flats around like 35 square meters, and two bedroom flats. I just make it a bit consistent. So 2-bedroom would be 70 and 3-bedroom 100, 105. But let's just roughly estimate. It's not like just from the source, I think it described like that. But for sure, the housing size range from different ways, and that we can certainly find other sources and find a more reliable resources. But that's the way how I calculate. I use the unit energy cost times the 52 weeks, and also times the average bedroom in each of the postcode sector, and get the information for energy cost per year. And then the next step is to actually import the weekly income data and connect with the postcode shapefiles, and just to merge all the data together. So it's quite easy to say here, but in the actual data science process, it's a fun process to find out all the joins. And the final part is actually look at the field poverty measures. And here I use 3 ratios between energy and income, rental cost and income, and also energy plus rental and income. So it goes to the next slides about the field poverty measures. So originally I have this idea to use Zoopla to look at field poverties because I'm thinking of like for a lot of rental poverties, the tenants typically will not have a right to further improve the building, right? So typically you will not allow to do it. And if they live in a quite expensive, they pay a lot of money for rent, expensive rent, but they also have to live in a very low energy efficiency house. That will actually, exacerbate their poverty levels. So that's kind of the very beginning. So ideas that say, oh, why I should look at this and see if that's true from my understanding. So here's like I have, as I mentioned from data analysis, I have a yearly energy cost, I have a yearly rental cost based on the postcode sector, and also the yearly household income based on also at the same spatial unit. And I can actually calculate the ratios, say the energy cost divided by the income. I call it as field poverty, but it's actually just a ratio, like how much money you spend on fuel out of your entire household income. And the second one is called, I call it rental poverty, but it's like how much money you spend, what's the ratio of money you spend on rent compared to your income. And then if we add it together, that's the entire ratios. So let's go to look at some of the maps here, which is exciting. So this is the first one. So the ratios between the energy cost and the household income. So I don't know how many of you from Glasgow or familiar with Glasgow. And we can certainly find out in the East End, we got a bit more of field poverties because that's kind of areas with low incomes and also old houses around the city center you can find out. But we also see some of the interesting patterns on the northwest and northeast. So they actually spend a lot of money on their fields. So that's the first map from this analysis. But if we look at the rental poverties, or say what's the ratio of rent they pay out of their incomes, and very straightforward, we find out the city center obviously the most expensive, and you can see like the West End is also pretty expensive area. So where University of Glasgow, and also you can find out. But when the distance growing, moving away from the city centers, you'll see you pay less rent out of your income in terms of a ratio, and you see the smaller is the 70% to 22%, and a city center is around 36% to 47%. So it's pretty high. But if we go to the field poverty, go to previous slides. So the highest ratio for the field poverties where you pay about 30% of your money up to the electricity and the gas. So that's actually a big chunk of money. So how it looks like when you add it up. So this is the last map. And you will find out since the city center has a pretty high rent, and we can kind of estimate that's the areas. But the finding is quite interesting. We find out the areas near the city center has the highest ratio to pay rent and energy together. The highest from around 60% to 75% is around the city center, and also the north of city center, which is not actually showing up in the previous map. And this kind of surprised me, and it will certainly need further investigation in a future research. Okay, so yeah, after the brief results and a few summary points here. So I think the first thing is, as I mentioned, field poverty has been observed in the east end of Glasgow, and as well as the northwest and southwest of the city. And high rental cost has been confirmed in the city center, and it gradually decreased from the center to the outskirts of Glasgow. And we find out the most deprived areas in the north of the city center in Glasgow, and which is quite interesting and needs further investigation. So here's just preliminary results of my research, but the result is still quite. I mean, it's just in the first stage, right? So we don't really go into any of the regressions, but the results actually illustrate the value of using the new forms of urban big data to understand field poverty. And more generally, that's a new way to tackle traditional urban questions. All right, so a few future work. So this one certainly has some capacity to make it more comprehensive. So I think first thing is that we can extend the study area, but we can extend it to Glasgow city region. It contains, I think, 8 or 9 city councils. We can extend it to major cities in Scotland, including Edinburgh, including Glasgow, including Aberdeen, and many other cities. And this data, the Zoopla data, available across the UK. So we can even extend it to the entire Great Britain, including England, Wales, and Scotland. But I'm sure that will require a lot of data processing power because the data set will much, much bigger. And also here we look at private rental markets, but how about homeowners? So it'll be quite interesting to look at homeowners as well. And also for homeowners, we also get a registry of Scotland data hosting UBDC, and that can be another resources to look at and also to combine with the Zoopla data. So there are many more analysis can be done. So right now we don't really explore what parameters actually, I mean, right now we only look at the rental cost and the energy cost, right? But we can look at what's the reason to cost this pretty high, result in this high cost. And the census data, or we can use the social demography information to predict, also to estimate, either through many different ways in terms of data set. We can use machine learnings, we can use spatial regressions, we can use geographically weighted regressions. So a few other things we can do in the future analysis. So yeah, I have one related publication, I mean, Reka's here, so it's great to highlight her. And yeah, so we collaborate on one of the field poverty and income deprivation research. We use the England data set in Bristol, and that's presented in a GSPLANK UK this year. And also this research will be presented later online. So that's pretty much what I have today. Thank you very much for your time to listening, and I hope this research will give you ideas how to use the new forms of data to look at the housing questions, and also can help you to have a better idea like how the data looks like and how you can get it from UBDC. And in the second half, I will go to the notebook, the Jupyter notebook, by using Python, and I will go into the more detail of the analysis and give you some ideas like how I actually achieve all these results from my programming. Thank you very much.
So we have some questions, or so far only one question, but please post all your questions in the webinar chat. So Will asked in the beginning of the presentation, how is fuel poverty defined? There are various ways to define it, so I don't know what is the exact one that you used.
Yeah, so let me see. Right. So the fuel politics, so it actually has many different ways to define. And one of the literature you can refer to is the Baker et cetera 2018. So in a Nature Energy paper, it actually describe in different ways. In different areas, they actually have different thresholds. Some areas say if more than 20% of your income spent on energy, that will be fuel poverty. And some areas say if more than 25%, it will be fuel poverty. And it also very depends on like the locations, right? If you're talking about Scotland and some like Spain, and so you'll be different in terms of the areas. So like UK needs a lot of central heating, but previously I live in Phoenix. So there's also fuel poverty problems, but that's basically people using AC to cool down the house. So it's actually, it really depends on different countries and different areas.
Thank you.
Okay. Yeah.
Any questions? We don't have other questions in the chat, so we can still wait a couple of minutes. Maybe someone will come up with another one.
Yeah, feel free to put in questions in the Q&A and happy to answer.
Yeah, I don't see any other ones, so maybe we can have the break now, and let's come back in 15 minutes for the tutorial.
Sure, yeah, that's good. And let's come back to after 15 minutes. And I will, so yeah, before we go, I will share the website. So if you go to my, I don't know how many of you use GitHub before, but if you go to my GitHub account, and my name is QSCHAO, and there's a repository called UBDC Data Dives 2020, and I put the slides and also a notebook there. So if you open a notebook, you can see the code there. So I will briefly introduce the analysis to you in about 15-20 minutes.
Yes, I posted the link in the chat, so everyone can have a look at the GitHub repo.
Okay, very good. All right, so I will see you all back at around 11. And you'll find out like a few repositories I use here, but the UBDC Data Dives 2020 is the one we use today. And here we have two files. One is the slides that we explained in the first session. And the second one is called Zoopla Fuel Poverty, IPESA notebook, and which is the data, not data, the code we'll go through. So here we go. So if you want to have the data, you can go to here, the main page of this repository, and you to go to code, these green buttons, and you can, if you don't know how to use Git, and that's fine. And also, I don't know how many of you has a background of Python and doing the programming and using the Git, but the easy part is you can just download a zip file directly. You will get an entire folder. You'll get one folder and for all the data here. Oh, okay, all the files here. So I don't put the data in the repository because they are pretty huge. Even though for the EPC data is 2.5 gigabytes, so I don't upload it here. But you can find out in the first page, in the first chunk, you will find out a few of the data source, and you can click the link actually through your website if you opened it. And the Joomla data, that's the UBDC website about the Joomla data, and it introduces a variety of different details. So we also have the APIs to get the Joomla data, and also a few of the processing historical data informations, the data tables. So in UBDC, we have a team of data science to focusing on processing data and analyzing data and provide the best service to our data users. So you can find out a lot of information here on the web page. And if you want to apply, you can just go to apply to use data, and you will get you will receive correspondence from our staff. All right. Let's go to the old version. Gotcha. Okay, so the EPC data, if you opened it, yeah, it's a bit slow here. Yeah, but this is the 2020 data set from Scottish government. You can download directly from their website, and that's the source. And the Energy Saving Trust, Scotland. If you search EPC data, Scotland, and you can find something called Scottish EPC Register. And here you can download the individual EPCs by just search by postcode. So this is a way you actually get a PDF. But if you want a machine readable, you will go here for the website. Okay, so weekly household incomes, you can open the link. I will not do it here. And also the postcode shape file, you can open the link here. So it actually contains, including postcode unit, postcode sector, postcode district. And also in postcode unit, it has a correspondent, the data, correspond data zones, different information. So it will be pretty helpful. That's a pretty helpful data set, I would say. So I don't know how many of you know Python, but generally speaking, you can just simply install Anaconda Python distribution if you want. And then you can run, I only use pandas and GeoPandas in my code. So that's not a big, that's not a lot of package. And this is a GitHub repository. All right, so you can see my code through GitHub, but I will open the, oh, no, sorry. I will open a notebook on my computer, and you can see it. So I already explained some of the information here, so I will not go through that. But here, very simple. Here's just, if you know Python, I don't know how many have a Python, but I will just give a brief introduction of the entire code process. And if I have any more questions, we can discuss there. So yeah, so here's I just import the package, the pandas, and the glob package is help to read the Joomla data in. And here's I give the path of the data, and then I just adding all the Joomla data to the data frame. And I already run it here. So but it takes about, in my a very good desktop computer in the university, and that takes about probably 7 to 8 minutes. So it's reading a huge amount, 44 gigabyte data into the data frame. And here's just a brief idea like how it looks like for the Joomla data set, right? So it has the listing IDs, property IDs, and I can actually show you the Joomla data here. Yeah, so here's the Joomla data. You can see in a spreadsheet. So you have listing IDs, property IDs, and a lot of different informations. Like this is the price. We have the postcode, code, outcode, and in code. And also they have a price change. So many other, like number of bedrooms, number of floors, number of bathrooms, the last marked date, many informations here. Postcodes, yeah, many informations. Okay. So you can see like the entire data frame is 1.3 million. No, it's 13 million actually. It's a huge data set. And I fill the data to Glasgow by using post-town fill, and it quickly filled down to 124,000 rows. And then I further filter the data based on the city postcode, right? So you can see I have a list of like from G1 to G5, like G12 is the University of Glasgow, and it's all the way to G53. And the code is basically filtering to the Glasgow cities, and now we have 71,000 rows of data. And since we're interested in private rental market in this analysis, so we use the listing status and set it to rent, and the data is further reduced to 17,000. And now we start to do some data cleaning. And first thing, I print out all the column names. It's just helpful for me to remember what's there in the data set. So the first thing I want to use is the last market day, which is the listing has been removed from the Zoopla website, right? So it kind of means that's reached the end of the advertisement and the rental activity is finished. But the first thing is I find out that a lot of zeros in the data set. So I basically say, okay, if you have zeros, I will just remove it. And it shows that we reduce from 17,000 to 16,000. But there's other ways, like we have the first market day and we can look at that information if we want to use it. So in the data analysis, there's always different rationales to make decisions. So that a lot of things can be discussed across the entire process. And to do it, the next thing I want to do is to actually convert the Panda series to datetime format. And the things like this will make it possible to look at different years and to match up with the EPC data. So the next one, I try to analyze the bedroom numbers, and we find out we have a lot of 0 bedrooms. I don't really know what happened there. So maybe studio and how they count it. And we also have really 22 bedrooms in the data set. So I think those are quite, I mean, a lot of them are basically, I would say they are outliers from a statistic perspective. So I only keep the bedroom numbers range from 1 to 5 and remove outliers. But basically we only remove about, I mean, certainly more than 1% of the data here. So it's not quite a big deal. So we reduced to almost 16,000 rows of data. And that's the new data set we have. And in the Zoopla data, there's also a status column, and it shows the status of the rental. And you can see that we have the rent under offer, rented, or to rent. So generally speaking, we can say, okay, probably to rent is not yet rented out, but just to be analysis, I would make it simple and I just include all the data here. So this can be discussed if we have we look at a UK-wide or Scotland-wide. Do we still want to include those to rent parameters of say the data? So the next cleaning is based on time. And since as I said, EPC data and Zoopla data have a different time range, and we want to align them together. So here I just basically clean the data from January 2013 to December, end of 2018, like December 2018, to ensure they have the same time coverage. And one thing was mentioned, I don't really separate different years, but that's something can be done accordingly, because we can only look at like in 2013 how it looks like, 2014 how it looks like, or say we can look at 2013 plus 2014, and we can look at 2017 and 18 and see if we have actually any rent increase. Sometimes that happens. So, but in this analysis, I don't really separate them out, but that's a potential direction to pursue in the future. So you can look at how many data we have, and 2013 to 18, we kind of cover the majority of the information for sure. So we further reduced to around 15,000 rows of data. And since the Zoopla data provide weekly rental price, so I just sort the rental price from the highest to lowest, and I just find out some interesting outliers. Like 1 week you pay 87,000 UK pounds, and to me it's quite a strange data, and it can be either errors or it can be outliers. So I set the weekly rental price less than 500, but 500 is still pretty high actually. So if you have 500 times 4, it's like 2,000 pounds a month. It's in some affluent area in UK, in Glasgow, that's probably happened. But that's just like more like experience, like roughly estimate. But actually, when I do it, it removes the top 1%. So here's the code how I do it in Pandas, and it only removes the top 1% of the outliers. So I don't think that really influenced that much, but that really helps us to focus on fuel poverty. So that's the data cleaning process, and you can find out the entire process is to looking at data. So in any of the data science project, you always need to look at the data and look at different fields you have, and you need to play around with different fields and see what kind of criteria can help you to better kind of extract the data set from a huge data set. So when we talk about urban big data, right? So 44 gigabytes, but we eventually down to like 14,000 rows in this analysis. If I export the CSV, it's probably only several megabytes. So big data can be narrowed down to small data relatively. I mean, it's not a real small data, but it's still big. But comparing to the original data set, the useful information is actually quite limited. And that's how it looks like for those kind of new forms of data. So a few of the manipulations. So I calculate the yearly rent by the weekly price times 52 weeks, and generate a full postcode columns easily. And also, there's a typo here, but generate a postcode sector column to match with the EPC data. Just remove the last 2 digits. And here I show a quick statistics of Zoopla listing in each of postcode sectors. And you can find out the smallest Zoopla listing is number is in G15, 7. There's only 7 listings across from, 13 to 18 across 6 years. So, but the highest is all the way go to 639 in G41, 3. So when we next thing we will do the average to calculate average rental cost in each of postcode sectors, and these numbers actually will be pretty important, because if we only have 7, that's probably, it depends on the area of the postcode area. I mean the size of a postcode area, but it really shows the representative of the price. Averaging 7 listing price comparing to averaging 600 listing price, certainly you'll get a different the data is not in the same level of reliability, right? Okay. So one thing we can do, we can remove some of these small numbers, but to ensure we have a full spatial coverage, I don't do it here. So yeah, another thing is that in the Zoopla data, we have a property type information, and final Glasgow City data set, we got the majority is actually flat. It's about 13,000, and we have 400 terrace house. We have some detached house. We have some cottage house, and we also have some semi-detached house, and we have some bungalows you can find out. So different types here. So yeah, just give you, I mean, majority is still flat. And you can imagine that's kind of how it happens like in the city centers or the West End, most of the flats rented out frequently and change tenants. So that's how it looks like. So the next one is to calculate the mean value for yearly rental cost in each postcode sector. And I use the group by function in Pandas. And you can find out the average yearly rent is ranging from around 5,000 pounds a year, all the way in G34, and all the way goes to the highest and goes to 12,000 pounds a year in G2. So that's the Zoopla data cleaning. So the next thing is I go to the EPC data. So that's Zoopla data is relative. I mean, I finish here. And the EPC data, as I mentioned, the introductions in the first part, so that's a few of the information. Not all the EPC available on the register. And the buildings newly constructed after January 2013. And also if they're drilling, sold or rented out after December 2008, they require to have a new EPC. And also the non-domestic buildings sold or rented to a new tenants and the public buildings from January 2013, they need to have an EPC. So it's not a full coverage of the entire building and the entire housing market in Scotland, but we keep accumulate, right? The data is keep accumulate. We have more and more data. So EPC data is 2.5 gigabytes, 30 CSVs. We have a coverage in Scotland, and so I can show you the EPC data here a little bit. So yeah, so here's the EPC data. You can download by yourself as well. So I use the date of assessment as I mentioned. That's when they generate the EPC certificates, and they have a total floor areas, and that's what I use to calculate the unit energy cost. But one thing is quite useful is this current energy rating efficiency. And yeah, one thing I just don't have time to do is that to actually generate like a histograms to show like what's the current Scotland EPC bands, and that will be useful, right? So according to the government documents, they want to move all the private, I think they want to move all private housing EPC to at least D by 2020, I think this year. I don't remember exactly in the government document, but they have a few goals, but it would be good to look at the data and see how difficult to achieve it. So there are many informations here, and you can explore, like say they have like water heating, how much you spend, and many also the environmental informations. Okay, let's back to the code. So we read the CSV file same as the previously the Zoopla data into the EPC frame. So we have about 1.2 millions. And I use the date of assessment as the EPC obtained date. The code actually find out a few errors in the EPC data. So it says the some of the years like in 3012 or some 3012. So actually there's typos in data set. So that can be actually corrected by the government. And you can find out some 1970s exist. And it's also 2103, something like, so those kind of things you can find out in the data set is actually error data. And I further just eliminate and filter down to the 2013, 2018 based on code here. And also, as we know, the EPC data is only at postcode sector. And this part is just to extract the EPC data to Glasgow city based on the postcode, same as the Zoopla. And then the next step is to actually calculate the energy cost per year per square meter, and based on the total current energy cost over 3 years divided by 3, right? And then also divided by the total floor areas. So this is how I calculate the unit cost. So here's the same as Zoopla data. We want to know how many EPC records in each of the postcode sector. And we find out we have a few ones like G20, G21, G32, 5. But we have really large areas that goes to 2,660. In G53, 7, we have 2,600 EPC certificates there. So this is actually quite an interesting phenomenon because you can find out like so there's 3 conditions to obtain new EPCs and launch them in the energy saving trust register. And I will probably say the G25 is a very stable neighborhood. Not that many people actually sell their house or rent their house out. It's quite a stable neighborhood. But some other postcodes that's actually frequently change tenants, frequently buying and selling houses. So that can also kind of represent the neighborhood dynamics in some way. So the next thing is I calculate the mean of unit energy cost in each postcode sector by using the group by, same as the first part in Zoopla. And you can find out the unit energy cost from around £7 per square meter per year to all the way to £23, really large, but mostly up to £12. So I finished all the cleaning and manipulations, and then the next step is join 2 data together. And I use the merge function and based on the postcode sector. And the next one is calculate, as I mentioned in my first part, calculate energy cost per year based on bedroom numbers from Zoopla data and a unit energy cost from EPC data. I mean, that's just the average number of bedroom statistics. And you can find out the average around 2 bedrooms. But still remember, I remove zeros, remove really high bedroom numbers. So we have only range from 1 to 5 here. And so the minimum is around 1.3, and the mean is around 2, and maximum is around 3 bedrooms. And as I mentioned, I use the space standard for homes, I think from RIBA, Royal Institute of Architecture. And it says it has a regulation for the 1-bedroom house, 2-bedroom house, 3-bedroom house. And then I use the corresponding measures to calculate the energy cost per year. So basically average number of bedroom times 35 times Zoopla EPC unit energy cost. And I generate this new field. And the next thing is it's basically adding up the information, right? Adding up the energy cost and the rental cost. And you can see that's from smallest of 5,600 a year, all the way goes to 13,000 a year spent totally on rent and energy, which is quite a lot of money. So here I finish all the analysis for Zoopla and the EPC. And the next thing is to adding up the spatial components of this analysis by use the postcode shapefile, and also add the weekly income information. But that's a spreadsheet, so it's the same using a pandas. And I use GeoPandas to read the shapefile, handle the spatial data set. And that's the National Records of Scotland for the postcode sector shapefiles. Yeah, GeoPandas is not as widely used as pandas, but it's quite a useful Python package to deal with the spatial data set, particularly in data manipulations, cleanings around the different shapefiles. And you can find out the district. So I just get the postcode district and filter the shapefile to the Glasgow city area. So same as previously. And then I merge Zoopla data and EPC data with the shapefile based on the postcode sector. And here's just a brief data, how it looks like. So you can find out a lot of data is already connected based on the same sector number. Then I read the income data from Scottish government website, panda.read.csv. And then in the income data, it has the mean value and the median values for each of the data zone. So it's under the data zone geography unit. And in this analysis, since I always use average values in the Zoopla data and the EPC data, so I also use the average income in this analysis. So I remove all the median data in the CSV. And since the income data is at data zone level, and I will need to convert it from data zone to postcode sector, and then I can join that with the previous straight file with the Zoopla data and the EPC data. So this kind of spatial unit aggregation is relatively time consuming if you use ArcGIS. I have done that before, but I find out through Python sometimes it's actually straightforward by using GeoPandas and Pandas. So this can be one of a reference for you to use. And here's I filter a new shapefile to Glasgow City. And yeah, I find out this shapefile is quite useful because you can find out it has a postcode, full postcode. It has the postcode district, postcode sector. It also has the console numbers. You also have data zones at 2011. And you also have a few other things too. So it's a very good reference file to actually connect different spatial units together. And then I merge weekly income data with a shapefile based on the data zone number, feature code here, and find out this is a data set. And I calculate mean weekly income for each postcode sector by using group by again. And you can find the weekly income ranging from 425 in G31 all the way to the highest 915 1 week. So it's a good, that's an average value. So that's how it looks like in terms of the income in Glasgow City. So we go to the final stage to merge all the data together based on the postcode sector. And this is the final Glasgow shapefile I have. And after that, you still remember 3 maps, right, on my slides. So that's the ratios between energy cost and income. And here I calculate those ratios. And since the incomes, the weekly incomes, I times 52 weeks. And this is the final data frame. And you can find out all the informations, like all the ratios has been added in the data frame. And another thing is to write the data frame to a shapefile. And then you can do whatever you want to do. So if you want to do some of the visualization, you can use ArcGIS if you want. And if you want to do some more analysis, like say, if you want to do further analysis like spatial regressions, you can use Geoda. You want to do GWR, you can use the GWR softwares. But also, those kind of things can be done in Python as well. So when you have a good shapefile, when you have a good data frame, that's easily plugging to different Python packages. You can use Python to do spatial regression, GWR. And if you want to do visualizations, you can use Folian, you can a few other things you can do here. So I don't, so here's the end of the data analysis. So I don't do any of visualization here, but I hope this is helpful for you to kind of understand how I reach my data science, data analysis results in my slides. Okay, so it's about 30 minutes. So I will stop here. Any questions?
We don't have any questions in the chat, but there seems to be an issue with the EPC data download. But I think that goes down to personal security settings on the laptops or computers.
Yeah, I think if you go here, you should be able to download the EPC data. So that's an open data set. I don't think they have any limits or you need to do any logins, no. So it's just freely download. I think for today, all the data is freely available except the Joomla data. So if you apply the Joomla data from your BDC, and once you have it, you can actually run through my notebook easily with all the data. And all you need to do is just to change the data path, right? So you need to change your data path to your own path. And that's the only thing you need to do. And then you can play around with all these informations. Okay.
Any questions? Please
Any
post
more
them in the
questions
chat.
here?
Let me try to answer. No? I don't think we have any more questions.
How long is page?
Karen is asking how long this page will be available to us.
Yeah, so the GitHub account, I will just leave it there, I think. So you will be able to access to it. And I don't think I will remove the code. It's yeah, there's no magic there. So I only use two package, Pandas and GeoPandas. So it's mostly just the data analysis. But I want to just give you this can serve as a reference to you. Like say, if you want to do similar things, probably not the field poverty, but similar data analysis by using Python, that can be one of the resources you can look at.
Yeah, Sarah is saying that she doesn't have any experience with Python, so it's a lot to take in. Yes, I think it is a lot to take in, but it's a good reference to use in the future if you want to improve.
Yeah, so yeah, if you're interested on this analysis, you can consider joining us in MSc of Analytics, and we have world leading researchers here to teach you how to use it. And Rekha is one of the student, previous students.
I felt the same way when I first did that Python.
I believe she learns a lot across the 1 year period of time, and she can do all these things right now, I believe. So
yeah, apply for the masters.
Yeah, if you're from UK or if from Scotland, you will also have a data lab scholarship, and you can apply too.
Yeah.
Yeah, thanks Karen for your statement. Yeah, I think that's helpful, and so, but a lot of this can be presented to the government, right? So they sometimes they don't have the data analysis capacities, and this will help them to understand how. So they have regulations, but to accurately identify the areas, that's sometimes not very easy, and this can actually support their decisions.
Yeah, Sarah is asking, how do you use your research to try to influence government?
Yeah, that's very good question. And so the first thing is, like, for us, we're always, as academic, and also we're working in social science, we always try to talk with the government, right? So we want to establish collaborations, and particularly in UBDC, we have a really good connection with Glasgow City Council, Scottish governments. We have a few projects ongoing between us, on transportation side, but also on housing side. And so I think one thing is actually to make contacts with them and to talk with them frequently. Not frequently, but basically we want to find the right person to talk to, and to also we do research, we publish papers, but after that, it's actually very important for academic to push to the next step, to move your publication to generate impacts. But how to do it? So it's like publication sometimes, because you always need to have some new things, right? You need to have new findings, and sometimes you will be slightly too advanced for the the public sector readers. So you want to present them clearly, like the findings, and also fit to their own their interest. So sometimes we have the similar goals but slightly different routes. So one of the important things that we want to merge those two routes and work together. I think that's the thing. That's a way I believe will be helpful. Yeah.
Any more questions? We still have some time, so if you have questions, just post them. Oh, we have a new question from Tatiana. I'm wondering about the data on income and its integration with the Zoopla data. You did not consider different years, right? I'm just wondering here, is there an assumption that income has not increased much since 2012, and that is this why you only have one data set for income?
Yeah, so the income data set is not widely available in Scotland, and so they stopped to collect the income data on the 2011 census. But we have another one coming, 2021. I don't know if they have the income data. So the 2014 income data is the newest data I can find. But there's another option is to use the SIMD, the Scottish Index of Deprivation. So it updates at data zone level. And I think I work quite frequently, every 18 months, and Reka has used it before for England, the IMD data. So that's another option. But SIMD, there's not exact number of the income. It's just a quantile. Like you can range from 1 to 0. And 1 probably means the poorest, so 10 means the richest. So, but because we want to calculate the cost exactly, so here I use this Scottish income data. So I would not say like after 6 years, the income will not change, but also our data for the EPC and Zoopla, that's from 2013 to 2018. So that's kind of within the range of our like Zoopla and the EPC data set. So so always the data alignment is difficult, especially as I show you in the notebook. I have done a few things to align on different postcode sectors, postcodes, but also temporarily we need to consider when the data actually happen. So we have a Zoopla data, EPC data, and we try to align them together. And the income data is relatively okay within the range. And so we always have some limitations in the data analysis, but we just need to find out a way to do it.
Yeah.
I hope that answers your question. Yeah.
We also have another question from Oleg about using Python instead of like classic GIS, and how you understand the shape is good enough to use in Python and not the classic ArcGIS or QGIS, I assume.
So I think those two are complementary. So if you really favor open source, you can use Python plus QGIS. That's the open source package. I mean, open source software of QGIS. But generally speaking, Python has many packages, and right now we have more and more GIS-related packages, as I mentioned. So GeoPanda is one of the data manipulations. Typically, previously, what I have done a lot of this analysis in ArcGIS, and they have like small database operation system through the attribute tables, right? And QGIS, you can do it as well. But to handle this 45 gigabyte data, it's almost impossible to read the data into the software because typically it can handle small data set, and probably of 1 gigabyte. I don't know if that will work, and it will probably take a long time to just read the data, and because it uses a lot of memories. But using Python is much easier. So I don't want to say like you fully stick to Python and don't learn any of GIS. I think you need to have some GIS knowledge, and particularly not everything available in, say, ArcGIS or QGIS, and that's available in Python. So the open source community, we continue to develop new code, like say for one of my research interests in spatial optimization, location allocation, location analysis. In ArcGIS, you can do it directly, but in Python right now, it still has a lot of caveats to like how to actually run it in a good way. And also the packages, how to actually align the GIS data set with the optimization. There's still some barriers. I think that in the spatial statistics, it has a pretty good progress in terms of making it open source. But in a lot of other things like hydrologies, geologies, I mean, ArcGIS can be very versatile. And so that's something you need to balance. And also in our master in urban analytics, we still teach Python, R, GIS together. So I would say at this moment, you still need to learn all of them. But probably after 10, 15 years, Python is good enough. Yeah.
Thanks. There's another question from Bill, which I think is a very good point. If we looked at the variability within high-level postcode areas, so if there are smaller private houses and high-rise flats, it might compromise the calculation of average values. I think that's a good question as well.
Yes. Yeah. Let me see. Right. So I would say like a lot of, I mean, high-rise buildings, certainly, say in the city centers, you see more and more high-rise buildings, and level actually, so one thing is that what we can do, so we can separate out house and flat in the Zoopla data. And so many things we can do, right? So we can further filter the data. So we only look at flat and we compare to house. But particularly in the Zoopla data, we don't really have information say that's a high-rise building and I mean, we have a house information, but we don't really differentiate different types of flats. I mean, a lot of right now near university, there's a lot of like brand new buildings, so student flats, and that like those kind of data is probably not even go to Zoopla because they have their own systems. So those kind of high-rise flats will not actually even show up in the Zoopla data set. So that's what I mentioned. The New Forms of Urban Big Data, they're always biased. So that is not like a comprehensive survey like sensors. We have a stratified samples, and then we can say, okay, that's a good representative for the entire population of analysis. But here, the Zoopla data, that's a private rental market. And also another thing is like, we can look at Airbnb. So that's a short-term letting, and Zoopla is more like a long-term letting, or say long-term renting. And we can also look at Airbnb in Glasgow. That's basically the short-term renting, and see what's the differences across these two behaviors, and do they influence each other. And time will be quite sensitive information here, because I mean, in COVID-19, we don't have that much tourism, and particularly in Edinburgh. So Glasgow is less like a tourism city, but you can see like probably a lot of Airbnb, they become long-term, they show up in Zoopla right now because there's not that many of tourists. So many things can be combined, and many new research questions can be raised and it can be analyzed. So I think there's a huge potential in this domain to push forward, like with different type of data, how to connect them together, and how to draw a useful policy recommendation and information. But that's a great question. Yeah.
I don't see any more questions. If you have them, just please pose them.
Yeah, we can be here for a few more minutes. If you have questions, just post it there. You have general questions, like for our center, for our master programs, or like for other research, I'm happy to answer.
You can also email any questions, and we're trying to get back.
Yeah. Feel free to email myself or Rekha. for the questions. We're happy to help.
I don't see any more questions coming up, so I think we answered everything.
I hope so. All right. So I will stop share here. Yeah, let me see. Go back to. Okay, I got a question in Q&A. So you say from Tatina. Okay, so wondering about data in kind. It's integration.
I think we answered that.
Okay.
Yeah, I think that was all.
Assumption that income has not increased much since 2000 and why only. Okay, yeah, I answered that question. Okay.
Yeah. Thanks all for coming.
Oh, good to see more come back. Oh, you mute?
Oh, yep. Sorry. Yeah, just did a PhD supervision I was doing there, so hopefully the session went well.
Yeah, we kind of draw to the end of the session, and we'll have a few good questions. Yeah, but if we don't have any more questions, we will stop here. And I would say thank you very much for joining today's webinar. And thanks more for the nice housekeeping introduction. And thanks Reka for help maintain the Q&As and help the entire process. And I hope this session will give you ideas like how to use the Neofonso urban big data to do some housing research. But also, as I mentioned, we as a data service center, we host a variety of different data sets, and you will have a lot of opportunities to do it. And yeah, so recently, I just want to do an advertisement. Recently, we have 5 posts in UBDC. That's the short-term post about 4 or 5 months until end of March. And we have a few options to do public transport index, to do mobility research, to do video analytics through the CCTV cameras, and also through the dashboard development. So if you have interest, you can look at those posts. And also the last one, we will have our last UBDC data dive by our very own senior lecturer, Jing Yao, on this Friday, Mo?
I think so, it's Friday, yeah, I think it's Friday.
Yeah, and on this Friday about using GIS to doing some of the location allocation analysis. So look at the website, and if you're interested, please register. Okay.
And just to say that we will be putting these sessions online on YouTube, but we need to make sure we've got transcripts and all that for them due to the new accessibility regulations. So they'll maybe take a couple of weeks for us, but keep an eye on the UBD site, and you'll see the videos and etc.
Right. Yeah. So I will leave my GitHub repository there, so you will access to it. And the data you can download the open data by yourself. You can apply the Joomla data, and the final video with the transcription will go to the YouTube channel of the UBDC. And keep an eye on our center if you want to subscribe our newsletters. And we always have a lot of things going on. And also this is the kind of the main research direction in the Economic and Social Research Council to invest in the data infrastructure. So we are part of it. All right, thank you so much. You have a good day.
Thank you, bye.
Bye.